Okay, good day. So we will be discussing asymptotes of rational functions. Okay, so let's have an example. A sample rational function. So f of x is equal to x minus 2 over x plus 2. So we have here a table of values. So a table of values will be useful for us to sketch a graph. Okay, and also f of x will be also y, no? Okay, so f of x will be defined also as the range, wherein x will be our domain. So let's find the values of x or of y given the set of values of x for us to able to find the graph. Okay, so recall that we just need to substitute the value of x. So for this case, we will be having -3. So replace all the x's with -3. Okay, so this will be -3 plus 2. So this will be -3 minus 2 will be -5. -3 plus 2 will be -1. Hence, our value will be positive 5. So this will be positive 5. So we'll also perform the same steps for other values of x. So if it is -2, so we just need to replace all the -3 with -2. So this will be -2 and -2. So this will be -4. -2 plus 2 will be 0. So this will give us an undefinable answer. Okay, so we shouldn't place a value of y here because we don't have a value of y if x is equal to -2. So let's try if it is -1. -1 minus 2 will be -3. -1 plus 2 will be equal to 1. So this will be -3. Okay, so if x is equal to 0, so this will be -2 over 2, which will be also equal to -1. Okay, so if x is equal to 1, if x is equal to 1, so we will be having 1 minus 2 will be -1. 1 plus 2 is 3, so this will be -1/3. Okay, so if x is equal to 2, so this will be 2 and 2. 2 minus 2 will be 0. Okay, so this will be 0 over 4. This will be 0. So we'll be having 0 here. And if x is equal to 3, so this will be 1 over 5. So this will be 1/5. So we would like to draw a graph given these values. Okay, so I'll be having a graph here. Okay, so let's try to place plot the points. So if x is equal to -3, this will be equal to 5. So this will be its position. Okay, so we don't have values for negative 2. However, if x is equal to negative 1, we will be having negative 3. So there is an intense change in position, no? So the position from the upper part of the Cartesian plane from negative 3, when the domain changed to negative 1, the position of our point easily dropped to the lower portion of the plane. So if x is equal to 0, so we will be having negative 1. If x is equal to 1, we will be having 1/3. So I think this will be on this position. So if x is equal to 2, this will be 0. And if x is equal to 3, we will be having 1/5. Okay, so if we plot the points, create a curve. So I'll be using other colors to... Currently, our direction of the graph was oriented from the right to the lower left, and as you could see, there is a disconnection of our curve from negative 3 to negative 1. So there is a disconnection. So let's try to examine if we will be having x at negative 4 and negative 5. What will be the value of y? So again, change these values to negative 4, negative 4. Negative 4 minus 2 is negative 6. Negative 4 plus 2 is negative 3 and negative 2. So the negative 6 over 2 will be equal to 3. Okay, so we'll be having 3. If x is negative 5, we will be having negative 7 over 3. Okay, so this will be 7 over 3. Okay, so let's try to plot again the point. So negative 4 will be at positive 3. And at 5, negative 5 will be 7 over 3, somewhere around here. So as you could see, our graph was oriented on this direction. Okay, so as you could see, there is a disconnection between these two curves. Okay, apparently, if we examine this part, so as we try to close it out to the portion from the negative 2, so let's try to approach the values of negative 2. So let's try to approach this part. Okay, so from negative 3, so let's have negative 2.9, negative 2.5, and let's try to close the values to negative 2.1. So we're just 0.1 away from negative 2. So negative 2.01 and closer, so this will be negative 2.001. Okay, so what will be the value of our y? So I'll be just copying the formula. So if x is equal to 2.9, so we will be having 4.41. Okay, so if x is equal to negative 2.5, so let's try negative 2.5. So we'll be having 9. So if we have x equal to 2.1, so we'll be having 41. So if we have 2.01, we'll be having 401, and if x is equal to negative 2.001, we'll be having 4001. So maybe we'll try to close this out. So negative 2.0001, so this will be 40 sun and 1. Okay, so as you could see, as we try to approach the value to negative 2, our value of y approaches positive infinity. Okay, so the graph will look like this. So it will just travel upward, so it will never cross this negative 2 line. However, the curve will rises infinitely to the upward direction. Okay, so that will be the effect of approaching this line. So let's try to examine this part. So if we try to approach from negative 1 to negative 2, so let's try to close this out. So let's say if x is equal to negative 1.1, okay, what will be the value of y? So 1.5, negative 1.9. So let's try to close this out. So this is already 0.1 away from negative 2. So let's try to negative 1.99, negative 1.999. Okay, and another one, negative 1.9999. Okay, so let's try to examine this out. So if x is equal to negative 1.1, so the value of y will be 3.44. So this will be 3.44 negative. Okay, negative 3.44. If x is equal to 1.5, so this will be negative 7. If it is negative 1.9, so this will be 39. If x is equal to negative 1.99, this will be 399. So if x will be negative 1.999, this will be 3,999, and if x is equal to negative 1.9999, this will be 39, almost 40,000. So as you could see, if we try to approach the value of negative 2, our y also approaches now the negative infinity. So if we try to plot these points, the graph will proceed on this direction. So infinitely downward the Cartesian plane as it approaches this boundary line. And this boundary line and this curves will never, this first curve and the second curve will never cross this boundary line. So it just get a little closer and closer. However, there will no chance that it will intersect or pass to this line, and this line is so called asymptote. Okay, so finding the asymptote will be an easy procedure. So let's have an example. So the earlier example, so f of x is equal to x minus 2 over x plus 2. When dealing with this asymptote is in a vertical direction, so in an upright orientation. So it is so called a vertical asymptote. Okay, so finding the vertical asymptote is an easy procedure. So we should first simplify. Second is get the denominator, and equate it to 0. Then solve for x. Okay, so examine this expression, x minus 2 over x plus 2. So this is already a simplified expression. Okay, so we're done with number 1. So get the denominator, x plus 2, equate it to 0. Okay, so x plus 2 is equal to 0, so x will be equal to negative 2. Hence, this will be our vertical asymptote. Next, let's have an examples. So 3x minus 6 over x squared minus 7x plus 10. So again, first simplify this one. So this will be this can be further simplified. So x factor 3 out on 3x minus 2. So this will be 3x minus 2. So x squared minus 7x plus 10. So let's try to factor this out. So maybe the factor will be x minus 5 and x minus 2. So we could cancel this one, x minus 2 and x minus 2. This will be 3 over x minus 5. So get the denominator, equate it to 0. So x will be equal to 5. So this will be our vertical asymptote for number 1. Okay, let's have example number 2. So f of x is equal to negative 3 over x plus 2 minus 1. So simplify this one. This will be plus 2 minus x plus 2 over x plus 2. So this will be negative x minus 5 over x plus 2. So this is already simplified. So this we should get the denominator, equate it to 0. Okay, so x will be equal to negative 2. Hence, this will be our vertical asymptote. Okay.